So, if you are getting into electrical and electronic engineering, the first thing you have got to get the hang of is how to analyze electric circuits. But what does that even mean? What's an electric circuit and what do we mean by its analysis? Imagine this, you connect a bunch of electrical components, things like resistors, capacitors, inductors, diodes, transistors, power supplies, together in a loop. This allows current to flow through it. That setup is what we call an electric circuit. To put it in a more formal way, an electric circuit is a closed path of electrical components through which electric current flows. When we deal with circuit analysis, we are basically trying to answer a bunch of questions about what's going on in the circuit. Questions like how much current is flowing through a certain part of the circuit? What's the voltage difference across a specific component? Which components are supplying power and which ones are consuming it? And how much power are they using? We also figure out things like equivalent resistance and other similar stuff. Now you probably noticed I have already dropped a few terms like current, voltage, power, resistance that we haven't really defined yet. So before we jump into the nitty-gritty of circuit analysis, we need to clear up these basics. Let's start with the most fundamental one, electric current. The word current usually means the flow of a fluid, like water flowing in a river. When we talk about electric current, we are talking about the flow of electrically charged particles, like electrons, protons, different ions, even these things called holes, that we will learn when we get to semiconductors. Basically, when these charged particles move through a material or even through empty space, we say that an electric current is flowing. That's the basic idea of electric current, or in other words, a qualitative definition. But if we want to precisely measure it, we need to express this concept mathematically. We define electric current as the rate at which charge flows over time. If charge q passes through a cross section in time t, then the rate of charge flow, that is current, is given by I equals to q by t. However, this equation is only valid when the charge flows at a steady rate. But in reality, current isn't always constant. It can change from moment to moment. If that's the case, this formula just gives us the average current over the chosen time interval. To find the actual current at any specific moment, we use the differential form, which is I equals to dq by dt. If you have dealt with calculus before, you will know that this dq by dt is basically telling us how quickly the charge is changing at any given moment. If you are not comfortable with calculus, don't worry, just let me know in the comments and I will explain it in simpler terms in another video. Moving on, the SI unit for measuring current is ampere, denoted by the letter capital A. So if 1 coulomb of charge moves past a cross section in 1 second, that's 1 ampere. Now remember, current is just the rate at which charge is flowing, but charges can be either positive or negative. Both types of charge can create current, and this introduces the concept of direction. If the current is due to the motion of positive charges, we take the direction of charge flow as the current's direction. But if it's negative charges like electrons, which is usually the case, the current direction is considered to be opposite that of the charge flow. That covers the basics of electric current. You can grab the note of this lecture, link in the description. In the next video, I'll work through some mathematical problems involving electric current. One more word before leaving. If you need any help or just want to support this channel, please become a Patreon member, where you will also find solutions to selective exercise problems. See you there.